Hello, you're welcome to this lesson. In this video, we are going to solve this question I have on the screen. The question says a man takes the ball of mass 150 grams such that it leaves the ground at an angle of 60 degrees with the horizontal and strikes the ground at the same elevation at a distance of 12 meters away as illustrated in the figure below. Determine the impulse of his foot F on the ball at A. Neglect the impulse caused by the ball's weight whilst it is being kicked. So this is the question you have, okay, and we have to determine the impulse. So let's look at what you are going to do. To do this, we are going to apply the principle of impulse, which says that's the principle of impulse and momentum, which says that the sum of impulse of external forces, okay, should be equal to the change in momentum, which is this formula that I have written here. So I can represent the term on the left hand side, which is the impulse with I. Okay, so I'm going to have I to be equal to change in momentum. Okay, so from what we have here, to find the impulse of the man's foot on the ball, we must know V1 and V2. Okay, but initially the ball was at rest, so that makes V1 0. So for that reason, we are going to have this term to be equal to 0. So our impulse now becomes mass times V sub 2. So for us to be able to find the impulse, we must know V2 since we already know the mass to be 150 grams. So let me write that down. M equals 150 grams, which is the same as 0.15 kilogram. Okay, so now let's look at how we can find V2. To find V2, we will have to consider the projectile motion of the ball since it was kicked at an angle of 60 degrees. So let's look at that. So let's say initially the ball was here and then it was kicked at an angle of 60 degrees. Okay, so it will move from this initial position to a distance of 12 meters. Okay, let me indicate that distance here. So a distance of 12 meters. Okay, so from the question, we were told that the ball landed on the same elevation. Okay, so its initial position and final position must be on the same elevation. So you're going to have something like this, and then this will be the 60 degrees. Okay, so this becomes our V, and this V will have components, which is the horizontal component and then the vertical component. So we are going to have the horizontal component to be V cos 60 degrees, and then the vertical component to be V sine 60 degrees. So we are asked to find the impulse of his foot at point A. So that tells us that our main focus should be on finding the value of the velocity v here. Okay, so that should be our main focus here. So to do this, we are going to consider the kinematics. So we are going to first of all look at the horizontal motion of the ball. And to do this, I will use this formula which says S equals S naught plus V naught multiplying T plus half AT squared. Okay, I'll use this formula to find the initial velocity. This is because we have the initial velocity in this formula and also we have the final distance and then the initial distance, which are values that you already know. So let's look at the changes that you are going to do to this formula that I have here. So since you are considering the horizontal motion and we know that in projectile motion air resistance is neglected, which means that there will be no acceleration in the horizontal direction. So that will make this term 0. Okay, that will make this term 0. I gave more explanation on this, so you can check out my video on projectile motion. I have the link in the description. So now let's continue. So this is what we have now. So let me rewrite this formula as Sx equals S naught x plus V naught x t. Okay, this is what we have now. Right. So our V naught x will be the V equals 60 that we have here. So we can do the substitution. So V naught x will be equal to V cosine of what? 60. And then we know S naught x, which is the initial position of the ball, to be 0, and then the final position, which is Sx, to be 12 meters. So you can do this substitution. So you're going to have 12 equals 0 plus V cos 60 multiplying t. Okay, so this is what we have now. So what I'll do here is that I'll make t the subject. Okay, so when you do this, you're going to have, let me write this, 12 equals V cosine of 60 multiplying t. So to make t the subject, I'm going to have t to be equal to 12 divided by V cosine of what? 60 degrees. Okay, so let's simplify this and see what you get. So we're going to have 12 divided by cosine of 60. Okay, so this will give us 24 over V. So this becomes our T. So we have one equation. Okay, so I name this as equation 1. So now what we have to do now is to find another equation which involves T and V. Okay, so that we can use them, so that we can solve them simultaneously to find the unknown. So let's look at how you are going to do this. So you have one equation, which means that we need another equation. So to do this, I'm going to consider the vertical motion of the ball. Okay, so let's look at this. So let's look at the vertical motion. So for the vertical motion, we are going to use this same formula. Okay, so you will have Sy equals S naught y plus V naught y multiplying t plus 1 over 2. Okay, so now, so since you are considering the vertical motion, we know that there will be a weight force, right? And that will be the only force in the vertical direction. So you are going to have the acceleration to be acceleration due to gravity, which is g equals 9.81. But because it points downwards, because the weight force points downwards, we are going to negate it. So you have this to be minus 9.81 meters per second square. So now we were told that the ball landed at the same elevation. Okay, so for this reason, you are going to have the initial position in the y direction and then the final position in the y direction to be 0. So that gives us sy to be 0 and then s naught y also to be 0. So now let's do the substitution. So you're going to have 0 equals 0 plus v naught y, which will be v sine 60. So you're going to have v sine 60 multiplying t minus 1 over 2 multiplying 9.81 t squared. Okay, so this is what we have. So let's simplify this. We're going to have 0 equals v sine 60 multiplying t minus, so half of 9.81 will be 4.905. So I'm going to have minus 4.905 t squared. Okay, so this is what you have. So what I'll do next is that I'm going to factor out t. Okay, so let me write this equation. So I'll rewrite this as t multiplying v sine 60 degrees minus 4.905 t equals 0. Okay, I factored out t. So at this point, I can divide both sides by t. To take out this t. And then when I do this, we are going to have v sine 60 minus 4.905 t to be equal to 0. So at this point, you can make t the subject, right? So we are going to have v sine 60 degrees to be equal to 4.905 multiplying t. So I'll divide both sides by 4.905, divided by 4.905. So let's simplify this and see what we get. So sine 60, okay, divided by 4.905. When I do that cancellation, I'm going to have t to be equal to 0.1766 v. Okay, so this is what you will get. So we have another value for t. Okay, so let's name this equation 2. So now we can solve for v by equating these two equations that we have. So let's go ahead and then do that. So to do this, I'm going to free up some space. Okay, so I'm going to equate equation 1 and 2. So we are going to have 24 over v equals 0.1766 v, right? So when I rewrite this, you're going to have 24 over 0.1766 equals v squared. So let's simplify this. So 24 divided by 0.1766, 1766 will give me 135.9. So I'm going to have 135.9 equals v squared. So you can square both sides to get the value for v. So the square root of 135.9 gives us 11.66 meters per second. So that's the value of v. Okay, so this v now becomes our v2 because that was the velocity of the ball as soon as it was kicked. So this v here now becomes our v2. So we're going to have v2 to be equal to 11.66 meters per second. So now you can substitute that back into this formula to find our impulse. So I'm going to have the impulse to be equal to the mass, which is 0.15 kilogram, okay, kilogram times the velocity, which is 11.66 meters per second. So this is what you have. So now let's simplify this and see what you get. So 0.15 times 11.66, this will give us a value of 1.749 kilogram meters per second. Okay, so this is what we are going to have. So this will be the value of impulse. Thank you very much for watching this video. Please make sure you like and subscribe.